This is my Honda 2008 CRF450R. I converted it into a motard this year after many years riding on the track. I was just getting older, too much to maintain, so I didn't want to continue to invest the money in rebuilding it every season when I can just get a new bike and get newer technology. But the 08 was one of the best motors, best carburetor, best frames Honda ever made, and many people have said that, not just myself. I love this bike. It's simple. There's no electronics with the fuel injection and all that, but it was really tough to get this thing tuned for the street as opposed to the track, because it comes tuned, you know, for motocross application, and really you're either idling wide open throttle or full braking most of the time. There's not much mid throttle steady cruising at all on the track. So getting that right balance of the jetting to get it to perform well on the street and not be choppy, backfiring, it was tough, and I had to take a lot of research on the internet by myself because there wasn't a really good source for it. So I wanted to put in a video up on YouTube so you guys can all kind of benefit from my learnings over the last 3 months in one spot. I'll have another video of details of the motard and stuff I did to it later on, but the biggest priority now is getting it jetted right. And as you can see, half of it's still apart. I'm still in the process of this, but while I got the carb off the bike, I might as well show you guys just some of the parts of how it's working and all the 7 fuel circuits that are integrated together to get it moving. So here we go. So this tuning order I came up with wasn't anything from any specific location, but it was more of a collaboration of internet searches, the Honda manual for my bike, and some of the forums like Supermoto Junkie, and also mostly Thumper Talk. But I came up with this tuning order that I found most useful. And first one is your constants, and I'll explain those later. Second is your float height. Third, go to the main jet. Fourth, the slow circuit. Fifth, you're gonna pick a needle, and then sixth, and the final one is your leak jet. What I mean by the constants is starting off with a clean air filter. There's no sense in tuning a dirty air filter, so use a clean air filter. Also, your fuel and air passages. There's countless Orify and fuel delivery paths that are machined into the barrels and body of the carburetor, and they all have to be able to supply the proper amount of fuel that the jet is delivering to them. And also, replace wear parts. The emulsion tube, needle, and vacuum plate gasket are the three that I can think of off the top of my head. The emulsion tube is what actually carries the needle, and so you have the needle dropping down into the emulsion tube with the main jet below it. On big bore single cylinder engines, there's quite a lot of vibration, and what can end up happening is when that needle is at a partly extracted position, it can vibrate and actually wear out the emulsion tube. So shown in this picture here, you have an emulsion tube with an actual green circle overlaid onto it, and in this dark area here you can see where the metal is worn away, and what that's doing now is it's actually passing fuel up through the main jet and into the carburetor body. Also in the needle you have excessive wear over here near the clip position, and then some minor finish wear, but still the decreased metal surface is allowing fuel to leak by. So that's what I mean. Go through the carburetor, clean it out, make sure there's nothing dirt blocking passages, because if you're trying to tune around mechanical deficiencies, you're just going to end up chasing yourself, and you're going to end up doing it anyway in the end after already putting effort into it. So just right from the beginning, start off with the constants. Get a clean air filter on there. Clean all the fuel and air passages. You know, blow them out with air. Get everything good to go before you even start messing with the jets. Number 2 is your float height. Should be 6 millimeters. The float height affects everything because all your jets suck from the fuel bowl. And when I say suck, I actually mean you have a fuel level in here, and you have one atmosphere of pressure pushing down on that fuel surface. Well, all the jets actually stick into that fuel level, and in the throat of the carburetor here, when you have high velocity air moving through, it creates a low pressure zone right here at this venturi. And that low pressure area combined with the outside atmospheric pressure the atmosphere is actually pushing the fuel from the fuel bowl up the jets into the carburetor throat. So if you have high or low fuel float level in there, you have a high or low fuel level. And in conjunction with atmospheric pressure, if you don't have a standard fuel level in there, your jets are going to be moving a different amount of fuel than they were intended for. So that's why it's important to have your fuel float height set perfect before you even start to tune jets or the rest of it, because that has an effect on every jet. How the main jet works is you have an air pilot screw. It's non-adjustable, but it passes air through the clean side, which is here, through this tube, and that's the blue. What happens is your float height sets the fuel level down here. So you have fuel up to here, which is burying the main jet pickup, which is down here. As air moves in through here, through this tube, it creates that low pressure area, and what's happening is fuel is being sucked up through the main jet, through this orifice, up into the emulsion tube area, and the needle, being all the way out, is letting the fuel just flow right up into here and mix with the air. The main jet for a 08 CRF450R should be a 178. And the thing about the main jet, the reason why I have basically starting with this one first is because no other jet affects the main jet at wide open throttle, which is where the main jet operates. But the main jet has a small influence on other jets at partial throttle conditions. So you doing anything else in the carburetor isn't going to make any change to your wide open throttle condition with your main jet. When the throttle's closed and the emulsion tube is supporting the needle, you have a small amount of fuel leakage up through the needle and emulsion tube taper, just because of the Venturi action that's going on right here. Even though some of the fuel is being sucked up through the slow circuit, which we'll get to after this, but most of it's being regulated by the slow circuit. Some of it's actually still being pulled up that main jet, leaking up through here and into the carburetor throat for the engine to burn. So that's why it's important to, when you got everything else you don't have an idea about, just get the main jet settled in first, and then that's one down. How this works is you have air, again, coming in through the air screw, the air pilot, and it comes and mixes in this section right here next to these drilled holes in the pilot jet. It pulls or sucks some of the fuel up through the pilot jet and allows it to go up this bore into the carburetor throat area. In conjunction with this one, you also have fuel being moved up through the pilot screw and through this bore, also coming up into the throat area. The motive force for these are the air that's rushing through the engine, not so much the air screw for the pilot screw. So it's kind of like two valves, or one valve and one jet, and in parallel they deliver us, the fuel that you need to idle the motor. The slow circuit affects idle to off idle performance in air fuel ratios. And there's two components of the slow circuit. You have the slow jet, which is this brass machined orifice that's non-adjustable. And then you have the pilot screw, which is this black thing right here. It's basically a valve. And the slow jet provides large step changes in fuel delivery to the idle circuit via an actual brass jet with a machined hole drilled in the center. And the pilot screw is a parallel fuel delivery path with adjustability via like this valve or screw with a tapered end up here to regulate the fuel flow in parallel with the slow jet. When properly adjusted, the pilot screw should be about 1.5 to 2 turns out from full shut, and the target air to fuel ratio is 13.5 air fuel at idle. A good benchmark to know if your pilot jet is out of range is if you achieve your best performance or your best AFRs with the pilot screw at 1.5 turns to 2 turns. So what that means is if you fully seat this pilot screw, meaning screw it all the way in, and then you back it out 1.5 turns or less than that, like if you have it out 1 turn, that means that you need a smaller pilot jet. All right, so you need to have this hole in this thing smaller. On the other side, if you have to really back this thing out quite far, like more than 2 turns, then what you need is a bigger pilot jet. So you need a bigger hole in this thing. So you should be in the range of about 1.5 to 2 turns from fully seated, and then you know that you're in the right you have the right pilot jet in there. So now that we talked about the main and the slow circuit, talk about these AFRs for a minute. I got to a point where I was trying to tune the motard just by hearing it run better, like the manual says, and but it's not really good enough metric to, you know, get it to where I wanted it to be. So what I ended up doing was installing an air-fuel ratio meter on the bike. It's powered by the onboard 12 volts. It's removable, so I don't need to leave it in all the time, and it's greatly helped me with tuning, especially the main jet and the mixture screw. So normally you'd be shooting for about 14.7 to 1 air-fuel ratios. That's going to give you that's the stoichiometric burn for fuel, what you would, sort of say the cleanest burn. But that's not necessarily where you're going to get the most power from. So I actually got this chart from Lycoming Aircraft Engines website, and they're claiming that the best economy is gained at about 16.7 to 1. However, max power is gained at about 12.5 to 1. If I could idle at 14.7 to 1 without my header pipe glowing red, I would, but I don't like how red and hot the exhaust gets on this engine at 14.7, and actually the engine doesn't even like to idle that lean. So I actually shoot for idling around 13.5 to 1, and as I will tune the needle later, I like to approach 12.5 or 13 at like wide open throttle. So after you have the slow jet dialed in and you're idling around 13.5, 13.5 to 1 or so, or you're happy with it, the next thing you want to go after is the jet needle. And the jet needle is mostly responsible for quarter to 3/4 throttle conditions, and that's going to dictate your AFRs through that range. You got two components of the jet needle: the needle type and the clip position. So the needle type is determined through this chart here, and this is off of a Kind webpage. Actually, I got this from Jets R Us, but it's a standard Kind FCR jet selection chart. And what it's saying is you have four alphabetic characters that determine what the needle is. So like the standard one for a Honda, the 08 CRF450 is an NJGR. So that means it's N, which doesn't change, J, which means it's a 2-degree taper, G means it's the L1 is going to be 76.45 millimeters, and then R, the last number, means it's got a diameter up here at the top at 2.755 millimeters. And basically you can see they're all in order. You use this chart to determine what condition you need for quarter, half, and 3/4. So you're going to use that needle chart to determine the taper, diameter, and length that you're going to need to achieve target AFRs, such as at quarter throttle should be about 13.5, half throttle should be coming down 13.2, 3/4 throttle 13.1, and then like I said again, wide open throttle maximum power is going to be 12.5, but I try to shoot for like 13.0. That's good for wide open throttle. I feel safer there. And your proper needle profile is going to produce the target AFR range. And using this chart, you just basically, if you need a larger diameter with the, to lean it out at idle or low throttle conditions, you're going to make this area bigger. If you need it richer, you're going to make this area smaller. Because remember, this is the taper of which the needle rides in the emulsion tube. So the smaller this area of metal is, the richer that your mixture is going to be, because more fuel is going to be leaking by. And then the needle clip provides gross changes once you get this profile right. So like I said, you shouldn't be, if you find that you're super lean down here and you're super rich up here, well, you got to balance that using the chart to get the profile that you need. And then once you have the profile you need and you get like a good linear change like this, then you can use the actual clip positions. And there's a clip that goes on each one of these, and that'll drop the needle up or down to make it richer or leaner overall. And the last jet we have is leak jet. You can see it's the smallest one. The leak jet it's the smallest one. It also has the smallest impact on overall engine performance, but it has a large impact on getting the whole event started. The leak jet is kind of like a bypass valve that sends a small amount of fuel back to the fuel bowl on each squirt. And if you're not sure what I'm talking about, check out a couple of the videos guys have posted about the accelerator pump in action. It'll make sense to you. So when you open up the throttle, your hand, it actually moves this pump here, and that plunger at the bottom acts on a diaphragm pump and actually squirts fuel out of this little brass, the brass nozzle inside that throat there. The purpose of the accelerator pump is to provide fuel to the intake tract upon initial fast throttle opening from partial or closed positions. When the throttle is quickly opened, the venturi action from that high velocity intake air in the throat, it's momentarily lost. And the accelerator pump is an actual, it's an actual diaphragm pump that squirts unatomized raw fuel onto the backside of the intake valves down the throat, so you can get the engine going and then regain that velocity of air. And because that velocity, that air velocity, is what you need to pull fuel out of the rest of the jets. So the accelerator pump gets it started, and the rest of the jets, they really take over, the making power. But to get there, you need the accelerator pump. So if you have a smaller hole, that means you're squirting more fuel onto the back of the valves. And if you have a bigger hole or a bigger jet, then you're squirting more fuel back into the fuel bowl. So that's one thing that's important to remember when tuning the leak jet. And the standard jet for the standard leak jet is a 55 for the 08 CRF450R. Here's a detail of what I was just talking about with the accelerator pump. You have the accelerator pump, which is right here, and that takes the suction off of the fuel in the fuel bowl. So fuel from the fuel bowl moves into there through this check valve into this diaphragm area, and as you operate the throttle with your hand, you actually move this plunger down, and it pumps fuel out this line. And your leak jet is actually right here. So some of the fuel actually escapes back into the fuel bowl into this area, but the rest of it comes up this pipe through there, and then it squirts out that nozzle right down the intake tract. So you can see how if you have a bigger hole here, you're going to get less fuel out here, and if you have a smaller hole here, you're going to get more fuel coming out that accelerator pump. One of the other circuits I just wanted to describe was the cold start circuit, or your choke. You have another jet that's in there. This one right here, this is your starter jet, and that picks up fuel from the fuel bowl. And when you open up that choke tube right here, you allow the fuel to mix with the air and drop into the intake tract. And that's all you're doing. You're just richening up the idle air. This is your hot start circuit. A lot of people confuse this with a decompression lever. It's not. The hot start circuit, it doesn't add any fuel. It adds air, because when these motors are hot, they need a lean condition to start. So what you're doing when you pull on that lever of the hot start is you're opening up a bypass for air to just escape around the slide and come into the motor to lean out the mixture to allow it to start in a hot condition. So with the air-fuel ratio meter I'll have on it, it has an internal resistance heater that has to heat up to about 600 degrees before the element works. So the bike started idling about 13.5, 13.7. And this is on a cold motor. So initial light cruising, we're up in about 14.0, 13.8, 13.5. And again, this is all on a cold motor, so it's going to change a little bit once we get up to temperature. So some pretty aggressive throttle here, and got about 13.2 to 12.9. Back to cruising, looking about the same in about the 12.9 to 13 range. Some mid-throttle hanging out still about 12.9, and then here's wide open throttle, drops to 13.2, and I would have liked to get a little bit down richer than that, but the bike's gonna, as the weather heats up, the bike's gonna richen itself due to the air density. So you can hear the accelerator pump there that we tuned also. Real crisp, sharp, very sharp bite. I mean, the bike's running good. It's not really deviating too much from 12 to 13. Here you got some popping on decel. I apologize for the gauge. This is actually a digital gauge, and with the frame rate of the camera and the gauge itself, that's why it flashes like that. So going lean on this we're on a downhill part right now, and you can hear the bike popping. A lot of guys say that's the sign that the bike is not tuned properly, but I'm not going to try to tune out not a throttle closed position. Again, that popping, I don't really mind it. So we're back cruising up the hill. We just came down, and I'm making a little adjustment to the air screw, the mixture screw right now. They're up there in the 14s. So we're on this corner, mid throttle, and then wide open. Hard to tell, but it's about in the 13s, 13.5 at wide open. Back to cruising around 13.0, 12.9 again, which is good. That's where I am most of the time. So I'd like to have a pretty clean burn at mid throttle, partial throttle. Pretty happy with it. I mean, you can see most of the time spent on the road, it's about 12.9 to 13.5, and that's really where I wanted to end up. And of course, so the main jet, which is a little on the lean side, you saw it bump up into the 14s. That's going to richen itself up as the air density goes down over the summer and the weather gets hotter. It's still springtime here in Pennsylvania, so hopefully I won't have to jet this thing again until next fall. So back from the ride, we got it idling at about 13.2, 13.0, that's good because it didn't change much from when we started. So we got the tune done. Everything's all set to go. Ended up a little bit on the lean side, but it's still springtime, so as the weather gets warm around here, the bike's gonna richen itself up. But really happy with it. Hope you guys learned something. And if you have any questions, of course, comments, leave them below. I'll try to get back to you.